Everyone, I'd like to introduce you to Dean Dela Cruz. He's an expert in both quality and lean manufacturing, and I'd like him to share with us some of his thoughts on quality and the different processes that center around quality that we need to know about. So it's all yours, Dean.
Okay, good evening, everyone.
Good evening.
Okay, great. A little bit about my background. I'm an engineer, and I used to work for an aerospace company up in Santa Barbara. I was involved in the development and manufacturing of inertial guidance systems. These are the systems that gives directions to rockets and satellites. And from the time that I left the company to go into consulting, the last product, if you are aware, is an inertial guidance system that is called NEAR, which is the Near Earth Asteroidal Rendezvous System. And the function of that system is to go around a small comet to understand it. In my engineering days, I got exposed in a lot of what we were talking about today, which is the quality management involving a little bit of process improvement, but mostly involved in engineering and product development. And that exposure made me aware of what quality control is, what quality assurance is, the differences between the QC and the QA. At that time, I was asking myself, when I see people walking around with their carrying products, little did I know those are inspectors, they're QC inspectors carrying those products someplace to take a look at them. So that I will share a little bit of what I know, and it might be a little bit different in terms of definitions from your book, but hopefully it will share some of the things that you may encounter when you go into different fields. So you may go into engineering or healthcare or businesses, no matter the industry is, but you will encounter what the quality control is, what quality assurance are. Even though quality control and quality assurance are interrelated, but they are actually different by definitions, and they are different by functions, and we will look into that. So since this is a short presentation, bear with me. I will go only on some of the, just to give you a flavor of all of these. But I'm sure Dr. Ray will provide you with the whole gamut of all of these from the book. So this is my exposure, a little bit of my exposure, and I'm just going to share it tonight. Also, what I'm going to talk about a little bit about process and quality improvement methodologies, and I would like to connect quality assurance and improvements because they are interrelated in some ways. They work hand in hand, which drives the company's goal of making improvements or making profits. I will talk about Lean Six Sigma, and I will talk about lean manufacturing in the concept of lean manufacturing. So those two exposures from engineering days and even today, my exposures in working with many different companies implementing Lean Six Sigma, it's quite interesting for me, and I hope maybe that you may get interested as well. So, the to begin, I'll talk about the two aspects of quality management, the quality control and quality assurance, as I know it. Um, First, we need to understand what quality is, and it's quite difficult to nail down what quality is, and then there's so many different definitions on it. It's very difficult. So I offer some of these things here that I came across. So quality is a degree to which a commodity meets the requirements of customers. Quality refers to how good something is compared to other similar things. And when used to describe people, we think of it as a distinctive characteristic or attribute of, you know, comparing what, and how they look like. In a customer perspective point of view or customer service, it entails providing efficient, quick, and friendly service. But the most common useful definition came from the business side of it, which is the fit for purpose and conformance to requirements. The fit for purpose is, we talk about the fit, form, and function of the product, the end product. So you may have a different definition, but I'm sure maybe close enough to this. I want to talk about quality control and quality assurance. They are, like I said, interrelated, but they are different by definition. So what is quality control? One is it's a way of identifying defects. It examines the quality, fit for use or purpose of the end product. The aim of quality control is to check whether the products meet specifications and requirements of the customers. So quality control basically handles the technical side of the things. They are actually the ones that are actually implementing what quality assurance is designed. So quality assurance is a way of preventing mistakes and defects. It's called defect prevention. So the difference is, you can see, is one is defect prevention, and the other one is seeing the defects. So another definition that I know about quality assurance is the way of avoiding problems when delivering products to customers. A declaration. You've probably gone over the ISO certifications. It's a guarantee or confidence that quality requirements will be fulfilled. In my engineering days, we call this declaration a mil specs. So we work on military specifications. Our components, our processes, our design are based on what is declared in the mil specs. So basically what quality assurance is looking at those mil specs, trying to understand them carefully, and designing a processes that can be used in the manufacturing of the product or design of the product that will meet the specifications. So it both works on internal and external guaranteeing or being confident, like I said, that quality will be fulfilled. So that's quality assurance.
Well, and Dean, I really enjoy these definitions because, we often talk about quality and it becomes this esoteric thing for a lot of businesses. It's just, well, quality is something, I know it when I see it, but in the context of operations, there really are processes for not only defining quality, but guaranteeing it and having systems to prevent defects and ways of avoiding problems. So there's a lot of steps to operationalize what we know as quality assurance. So I appreciate these definitions.
Okay, thanks. Yeah, so it may be different than the way you would see it in many different books, for example. So that's quality assurance. And by now you could see the difference between QC and QA. And let me just reemphasize here in a different way. And the difference between QC, which is quality control, and QA, which is quality assurance. And quality control, it focuses on the product, whereas in QA, it focuses on the process. QC, quality control, is reactive versus QA being proactive. QC is performing a line function, which means that it's actually directly involved. The people that are actually building or actually touching the product is the line function, the QC. Whereas this is in the QA, it's performed by staff, typically engineers or managers. QC's role is finding defects, and QA is preventing defects. So that's the distinction between the two that you may encounter. So no matter what the product that you build or the service, you will encounter similar type of activities between the two. Examples of quality control and quality activities. Quality control activities that have walkthrough, testing, inspection, and checkpoint review. Walkthrough, I remember doing a lot of these because we work as a team between us, the engineers, and the software developers, the people that write the codes. They will do a walkthrough with us, and the purpose of walking through is to solicit ideas and gather some information. Walkthrough is like going through step by step of the design, highlighting, for example, if they're writing codes, therefore they will go through the code step by step with us to solicit ideas. On the next quality control activities, is testing. Testing could be done, you may hear in the field as a destructive testing, which actually the consumer reports do that a lot. And visual testing is just looking at inconformities, and maybe electronic or laser-based testing using equipment. Inspection, that's manual inspection, or visual, just done by quality control inspectors. And also one thing I remember doing a checkpoint review. This is more like a milestone. So when we're doing a product development during, again, my engineering days, we will do a checkpoint review at specified time to go over the design for the purpose of collecting data, the data that can be used by quality assurance management for analysis later on, or even our design group. And so there may be more quality control activities, this is what I can remember. Now, under the quality assurance activities, they're doing audits. They define processes, they identify tools and select tools to be used, and they train on quality standards and processes. So if a company, for example, is certified in ISO, they're responsible for training the content of the ISO and processes. And in our case, the mil specs. They train the manufacturing and quality people on the mil spec standards. Okay?
Well, and for the purposes of our class, when Dean refers to ISO, that's International Standards Organization. So basically, there are these industrial standards that I think were born out of the aerospace industry, where you have participants in ISO having to document what their operational quality standards are, and show that they have documentation of accountability, documentation of quality assurance, and those things go throughout the entire chain of command throughout a company. And then, of course, mil spec deals with military specs. So there are a lot of different standards for what we call military specs. But again, those specs, anyone who creates products for the military will have to meet certain specifications for that. Dean, would you also say too that this is sort of a continuum? In other words, quality assurance kind of informs itself through quality control activities. So there's kind of a learning curve where both sides kind of go back and forth and share results. And so one side should inform the other, and then the feedback from the quality control activities helps further refine quality assurance.
Yeah, absolutely. Now, quality assurance, before they can do their work properly in trying to defining or redefining processes or identifying tools when making improvements, for example, they need to have information, and then typically they work hand in hand with quality control departments to get those information. They work with engineering department to get those information as well. Yeah, so they're, like I said, they are interrelated in terms of activities, but they do perform different functions.
Yeah. Well, I think it's important too to keep in mind that you can have quality assurance as much as we usually think about these activities as related to the manufacturer of products. These activities can also be utilized for services, or let's say you're a wholesale or a retailer, or you're a warehouse. So this could be applied to a lot of different activities.
Exactly. Yeah. So no matter what the industry is, maybe the definitions and activities might be differ a little bit, but the overall purpose and objectives they are all similar in most activities. Yeah. So when I go back a little bit about the training or quality standards, I believe I'm not going to go with the ISO thing because that will be part of your. I think I saw that in your book, right? So there's not a whole lot of time for that as well.
Yeah, we could certainly spend a whole class on what that is, but just so everyone knows that it's a standard that's very common, particularly in the aerospace industry.
Yes, exactly. And if you want to do business or export products in Europe, they are the ones that are actually requiring ISO. You have to be ISO certified. So there are different numbers of ISO, and I think Ray will cover that in his class further on.
Yes.
Okay.
All right.
So this is in a nutshell about the QC and QA activities. So moving on, I'm going to go touch on quality assurance and process improvement. Now, previous slides I mentioned that quality assurance is kind of like proactive versus reactive in the quality control. But and most experts believe that quality assurance cannot be proactive without process improvement. It just can't. So the quality assurance and process improvement is really the two key areas in organizational development or performance of an organization. So let's go on some of the definitions. So QA is about monitoring procedures. On the other hand, quality or process improvement refers to the techniques used by organizations for continuous improvement. Quality assurance is done by quality assurance engineer. I mentioned that. Process improvement is a responsibility of all the employees in the organization. Now, having said that, this is where the advancement of process improvement, from the time that I started in engineering, there's not a whole lot of involvement by employees. Typically, engineers will tell people how to do their job. And the advancement of the methodology, which I will talk a little bit later, but the methodology of quality improvement and process improvement is more involved in the employees. The employee has more say by providing and assisting, staff in the development of process. Big change. So both are concerned with continuously increasing the quality and process standards in order to increase the productivity of the organization by reducing costs and improving the delivery time. And I kind of emphasize here, underline productivity, reducing costs, and improving the delivery time. This is where the proactiveness of quality assurance are coming from. So having said that, let's look at process and quality improvement. Well, there are three methodologies that I'm going to share with you, talk about here a little bit. It's called Lean Manufacturing, Six Sigma, and Lean Six Sigma. Let me go to the next slide. So when we say that quality assurance identify tools and processes and identifying equipment and so forth and so on, there is a set of techniques and tools for process improvement. And one is the Six Sigma methodology. And the Six Sigma methodology, what it is really a heavy use of statistics. It is a rigorous implementation of quality principles. It aims for error-free processes. That means it should be, any process should produce nothing but zero defects. We'll talk more about that. It uses facts and data, statistical analysis, and I'll show you some examples of what those tools are. I will mention it. It's introduced by an American engineer, Bill Smith, while he was working on Motorola in 1986, and I believe it's further developed by a couple of other companies, Honeywell and maybe GE, if I can remember right. Now, so Six Sigma is a measure of quality, which is to strive for near perfection. And as an example, you're talking about a perfection is a 3.4 defects per million opportunities. So I'll show you more the scale of that later on, but it's going to give you an idea that the measure of quality is striving for perfection is not that easy. Even Motorola, who developed this thing, really, they're not perfect. Okay, so some of the tools in Six Sigma, SPC, you guys probably heard about this by now, maybe. And we use statistical process control to analyze the effect of variations in the process. We use failure mode and effect analysis. It's more for engineering, where we evaluate potential failures in a product. Use the histogram, that's collecting and grouping of data, Pareto analysis, design of experiments, fishbone diagram, control charts, standard deviation regression analysis, and of course the most famous is the DMAIC, which is the define, measure, analyze, improve, and control. Again, I'm showing the tools of Six Sigma, but this will be, I believe, Ray will cover a lot of these things in your class in more detail, each one of these. I think he might have examples for each one.
Well,
in fact, maybe you guys are familiar with this.
Yeah, and in fact, Dean, one of the things we did in our last class is we talked about forecasting. And so I gave a little bit of an introduction to some of these statistical processes, like Pareto analysis, doing a regression. We haven't gotten to fishbone analysis, but certainly standard deviation and histograms. And so we experimented a little bit with those ideas, and we have some exercises that our class is doing. But I think what's really exciting about it is a lot of these statistical analysis processes are really easy to learn. We're not talking about advanced econometrics. We're talking about some basic statistical skills that enable you to bring a company to the next level in terms of quality and troubleshooting and strategic planning. So for me, it's really exciting that some very basic statistical tools can be used in a really powerful way when applying it to operations management.
Right, and there's a lot more involved in these tools of Six Sigma. For example, under the control charts, and there are several of these things that are used to analyze the process or results of the deviations. Okay, so just want to give you some of those tools. Now, another set of techniques and tools that we use for process improvement is called lean manufacturing. It is actually a philosophy. The principles, as much as it's not just a tools, except. So it's not just an application of tool, but it's actually a philosophy. By definition, and this is, if you go and Google lean manufacturing, you're going to have a ton of definitions in lean manufacturing. But this is the manufacturing definition that I use from my certification from NIST, which, by the way, I'm certified in lean manufacturing and Six Sigma by National Institute of Standards and Technology. So it is a systematic approach to identifying and eliminating waste through continuous improvement in pursuit of perfection. Now I'm adding waste in our presentation here, and I will go over a little bit more about that later on. So lean principles are all about the reduction of waste or doing more with less, which is based on the Toyota production system, which, by the way, Toyota production system came from the work of James Womack, who is the author of The Machine That Changed the World. You remember that book? And Lean Thinking. And those are two popular books that he wrote upon observations of the Toyota production system. And that's that lean principles or lean manufacturing or lean production came about out of that Toyota production system. The TPS is actually developed by Mr. Taiichi Ohno, the Japanese. It's considered the father of TPS, who adopted the concept of just-in-time production. So lean manufacturing focuses on adding value, and another terminology here that I will explain a little bit more later for the end customer, whether that customer is internal or external customer. Okay. So if it's a set of tools and techniques, and we have the definitions, a systematic approach, we have to understand what value is first. what is non-value? And we mentioned this that value is a capability. And we talk about process improvement and bringing quality, better quality for the customer. Value, we need to understand that in a different way, because this is now we're talking about capability. Value is a capability that you provide the highest quality, the right time, and appropriate price. And it gets a little bit more complicated and difficult to achieve. Now, value added on the other hand are activities that the customer must be willing to pay for. You know, what does that mean? I think this, in a day-to-day basis, you don't want to pay, customer doesn't want to pay for something that they don't need, or if the production or the make of product is so wasteful, customer doesn't want to pay for that, right? If they spend twice to build the product, customer doesn't want to pay for that either. Right? So value added are activities only if the activity must change the product. That means anything in the perspective of manufacturing or producing a service, the activity that you do must be related, directly related or touching the product.
Yeah. In fact, Dean, I think what's so important about this slide and the whole discussion of value, because one of the things we're going to be talking about in this class too is product design. And so I remember meeting a famous product designer, and one of the things he always talked about is this market first approach, where you're really focusing in on making sure that your products are solving a problem or fulfilling a need. But to extend that definition of fulfilling a product or need, it also has to be, as you said, the highest quality at the right time, appropriate price, but also have something where the customer is willing to pay for it. And then the opposite of that value, as you said, is waste. And waste is the opposite of those things. It's not fulfilling a need. It's the customer doesn't want to pay. Whatever the customer doesn't want to pay for is by definition a waste. So I think that's real important, because a lot of times we think of waste as we think about it in sort of these fuzzy terms that when we talk about lean, we often think, well, does that mean you're cutting costs? But not really. You're really just eliminating the waste. And so I think these definitions are really important for an operations manager, because it helps you focus on not only what value is, but on waste, what is waste, and what are these definitions that help us organize around it.
Right. Okay, so that is pretty much about what value is and what is non-value added. And the opposite of that is, like Ray mentioned, is waste. And then there are 3 different types of waste. And all of these are based on the Toyota production system. Is that where it came from? And you will notice that number 1 is muda that caused waste. Waste means muda is absolutely waste. There's no question about it. It's not necessary or wasteful in terms of whether maybe in materials or processes of doing the work itself. Number 2, mura is unevenness, non-uniformity. It's the same thing as what we say in Six Sigma as variance. Non-uniformity is actually a result of having different results in production of a product or service, for example, that doesn't meet the requirements or a threshold if you talk about quality inspectors. The third one is MURI, unreasonableness, too difficult, overburdened. And this is just basically asking people something that is so impossible to achieve. I know it's not really much of a, in terms of coverage in the applications of lean, the mirror doesn't really come into play that much. But we will talk about waste and unevenness later on. So those are the three types of waste. And I'm mentioning it because, like I said, lean manufacturing or Lean Six Sigma focuses on elimination of waste. But Toyota has done a very good job at classifying this and making it so simple for us to use. So there are 8 forms of waste. Now, in terms of manufacturing, distribution, or healthcare, now they are classified or categorized as one is defect, overproduction, waiting, not utilizing people's skills, transportation, inventory, motion, and extra processing. So if we will have to identify and measure our performance in manufacturing, 8 forms of waste it comes a long way. It's very useful for organizations for making improvements. And quickly, defect is basically producing errors. Overproduction is, in terms of lean, is producing more than what is needed by the customer. So when you overproduce, like the picture there, you have a ton of products sitting on a desk and along the desk, waiting for processing is considered a waste. Waiting predominantly in any organization, waiting is the number one. Can sometimes be number one. I mean, exists in almost all operations. So waiting for approval, waiting for signatures, waiting for parts, waiting for customers, you name it. Not utilizing people's skills. If we assign people not based on their talents and skills, not utilizing their skills or involving them in process improvement, for example. Transportation is also a form of waste. Transportation waste is when you move raw materials or products in many different directions. It's considered as transportation waste. I have a client that was struggling to really cut down on their transportation, and that is because of the space that the limitation of the workspace that they have. So what they do is they take some of their units out in the morning and put them in the parking lot so they can create space inside the manufacturing floor. And then at the end of the day, they put them back. So they spend about 2 hours a day just moving those things. Inventory is a waste. As you know, inventory of raw materials or finished goods or work in process. It's a waste when you keep too much of what you may not need. So why is it that inventory is a waste? When you keep too much inventory, some would say, well, the associated cost of keeping them, besides actually purchasing them while you keep them in the storage. Next is motion. Motion is categorized also as a form of waste. When the funny story I have about here is that one of the projects I did with actually a picture that, which makes egg rolls. It's called Windsor Foods back in East LA. People are so busy, and when we videotape them, we notice people are so busy and actually not really doing anything. And motion waste is also reaching in for parts or raw materials further away from the place of where they work on the parts, walking back and forth to correct mistakes. and motion waste. Extra processing is another waste, which means that when extra processing is a waste when doing more than what is required by the customer or what is required by quality assurance. So when quality assurance defined what processes and how it should look and conform to requirements, extra processing may be doing more than those requirements in order to make it look good, but it's not necessary.
Yeah.
Okay, those are non-value adding activities, and it directly impact on cost. Now, why is that? You would ask. Well, when waste exists, you're consuming resources. That consumption of resources is depending on is directly proportional to the amount of waste in the processes. Okay.
Well, and Dean, what I think is so good about those 8 wastes as they're defined is just in and of themselves, they sort of form this checklist for an operations manager. I mean, if you're managing an operations, these are great questions to ask yourself, you know, what about defects? What do we know about them within our operation? You know, are we overproducing? Are we batching things, thinking that has an advantage? Or, you know, the wait time, do we have excessive wait time? And not utilizing people's skills. I mean, I see that as a huge one where we're literally not using all of that intellectual horsepower that comes from our staff that may have ideas that can help drive our value. And so I love these 8 wastes because they're almost like a management checklist to go through.
Yeah. Okay. So that's in a nutshell. Okay, and then there's a lot more to talk about this, but just to give you a flavor, there are tools of Lean Six Sigma as well. Hello?
Yeah, we're here. We can hear you.
Oh, okay. Tools of Lean Six Sigma, and now I'm focusing on Lean. And there are so many tools in Lean. Number one, if you heard about it, maybe by now, it's called value stream mapping. It is typically a graphical representation or like taking a bird's eye view of an operations, whereas it studies the flow of materials from the time they are ordered from the supplier and delivered to your doorstep, the manufacturing floor, processed through in the production system, placed and completed, inspected, goes through the stock room, or directly shipped to the customers. At the value stream, the difference between a flow charting technique with the value stream, you are also collecting information. It's actually investigating or evaluating the flow of information. Who's doing and who's telling what in production. Now, this is oftentimes, sometimes you will find in manufacturing where problems exist. They're telling them so many different ways to do things, and it complicates with one another, and the result is delay. Another tool is 5S. I don't know if you heard about this. It's called a workplace organization. It's a technique for organizing a workplace, a garage, for example, a stock room, a warehouse, you name it. And it's a process that consists of sorting out needed between needed and unneeded items in the workplace and getting rid of those that aren't needed, making space, creating space for work, sorting out those that are needed, sorting them out in order, or organizing them in an order in a way that you can see them easily. Shining, which is cleaning by inspection, uh, sorting in order, sustaining, and shining. I mentioned that. Then the setting in order, and that is creation of shadow boards. You've seen this in Home Depot, where you see different materials are or equipment are are hanged on a wall and labeled. In manufacturing, you would see this where units are outlined in a shadow board, so that at the end of the day, the purpose is workers at the end of the day can place back the tools or equipment that they used during the day. Um, the good thing about the 5S is that, for example, um, a company could be searching for a forklift, believe it or not. How big is a forklift for you to spend a lot of time looking for it? And that's because they are misplaced at the end of the day. Now, doing a 5S, it creates a what we call a shadow board for the, oh, but it's instead of a shadow board, excuse me, but it's an outline on the floor where it designates the location for that forklift.
Yeah. In fact, Dean, I'm
Another
trying to remember back to my own Lean Six training, but as I remember, I think the rule of thumb is if you have a tool, you should be able to find it within about 30 seconds of needing it, something like that.
Yeah, well, it's less than that. So when you're employing a shadow board, usually typically a shadow board when they are located in close proximity to the workstation or within reach of the operator, it shouldn't take 30 seconds.
Yeah, and we often think back about workplaces where, you know, we're looking and looking for something. And when you think about, you know, a factory or a situation where you have hundreds of employees, when you add up all of those moments of not being organized, trying to find something, those minutes really add up.
Yeah, so it's a process of creating a workplace so that everything is in place in the right quantity at, and you have it at the time that you need it. That's what it is, the essence of 5S. Now the next one is cellular manufacturing. Now cellular manufacturing, cell manufacturing, is a plant layout design, and it's different than a functional layout design or product layout design. A cellular manufacturing is is putting together different aspects of manufacturing to produce a part in proximity with one another. In other words, it could be 5 different steps in processing or workstations instead of a line assembly where you had these 5 stations separated or lined out. With the cellular manufacturing put those together in a U-shaped fashion. In other words, they are arranged in like a U, letter U fashion, whereas the product comes in from one end of the the line or the U line, and the product goes through the process of 5 stations and come out the other side. Okay, that's the simple explanation for that cellular manufacturing. Um, Typically, it manufactures the same product. It cannot manufacture multiple different products. It's set up to produce the same product on and on and on and on. Okay, the another tool is a one-piece flow or continuous flow. A one-piece flow is the opposite of a batch flow. A batch may move materials 5 or 10 or 100 pieces at a time, and a one-piece flow process is where that's how you can achieve a continuous flow in manufacturing by allowing only what is allowed by the next process you can control the amount of inventory in between operations, and allowing the exact amount of utilization of resources, and it saves on utilizing space as well.
Yeah. In fact, I think one of the misconceptions in any kind of production is that, well, in order to maximize production, you have to go faster, right? But really it's about flow. Rather, with that flow comes speed, not necessarily rushing through something, but having the proper flow. So it's kind of an interesting concept.
Yeah. Yeah, Kanban or pull system. Kanban is a card that designates movement and signals, either to produce or move materials. That's Kanban. And it's typically utilized in a pull system. The difference between pull and push system. In a push system of manufacturing, products are built and pushed to the next workstation, regardless whether the next station is ready for it. In a pull system, the receiver pulls products or parts from a supplier, and without that, and using a Kanban, the signals that pull. Without the Kanban, the pull system will not function well. So Kanban is a visual cues to move or start production. Standardized work, that is actually basically just making sure that the production of product is built the same way in different times or different days, no matter how you feel about it or your mood. Standardized work allows you to produce the same quality part by following those. SMED is a single minute exchange of die. This is where Toyota came really very successful. The single minute of exchange of dies, but it's also developed by Toyota. It's a means of interchanging tools to produce from one type of model or part to another in 1 minute. So the tooling, it's about setting up a tool to produce another unit in 1 minute, and that's incredible. Takt time, also introduced by Taiichi Ohno, works with the pull system. It's a German word meaning beat. In other words, if the beat time or takt time, say by design, the manufacturing should produce part every 5 seconds, then takt time is 5 seconds. In other words, the production should produce every 5 seconds. Then we have 5 Whys. It's also used by Six Sigma. Have you guys heard about 5 Whys?
No, they haven't been introduced to it yet.
Okay, I'm just going to say a little bit. 5 Whys is basically like a kid asking too many whys. It's a process for determining the root cause of a problem. So it's a root cause analysis tool, but it's simple. It doesn't use any statistical analysis, but just basically asking 5 whys. Why is this? Why is that? Until you are satisfied that you have reached an answer to a problem. And typically, the answer to the problem should point to a process, not an individual, not something that, Peter forgot to do this. And that's not a conclusion of 5 whys. So in other words, you continue asking the whys until Peter is not the problem, but rather the process. Put it simply that way.
Well, and it's such a great technique because often as operations managers, right? Well, why did this happen? Well, the truck was late. Well, okay. Whereas you should have asked, well, what happened? Well, the truck's late. Well, why is the truck late? Well, the truck's late because we placed the order late. Well, why was the order placed late? Well, the order was placed late because the system was down. Well, why did the system go down? Well, it always goes down at 12 o'clock. Well, why does it always go down at 12 o'clock? Well, our IT guy is out, and you keep asking those questions until you actually get to, as you said, the root cause. So it sounds like such a simple thing to do, but we often don't dig far enough into the root of certain problems.
Exactly. Yeah, we only do one why. Another root cause analysis tool is mistake proofing, or Pdca, and this is avoiding mistake before it happens. And typically you will see this as like a device, or like in a gas station, you will not make a mistake of filling up unleaded gasoline to leaded gasoline. That's because the mistake proofing, Pdca. Total productive maintenance is the opposite of preventive maintenance. Pdca, so this is the process of making improvements. Typically involve a team or a group of employees. What they do is they plan the project, they define the project, they analyze the problem and the issue, and they do design their solution. They check the solution to see if the result matches with the required results or requirements. And then when it does, they act on it. Act means implementing in a formal way. And if it doesn't check with the requirement, then the whole cycle restarts. The plan and go back to the P, planning and doing and checking until they are sure that the process yields based on requirement or conforms to requirement. Kaizen is the terminology for doing Pdca. So that's a group of people. Kaizen is the Japanese word meaning continuous improvement or doing good. Load leveling is used by car manufacturing companies by being able to distribute the resources properly and able to produce different models. They use a type of techniques called load leveling by maximizing the amount, the equipment by the amount of time during the day. Load leveling is used for mixed mode manufacturing, mixed model manufacturing. And A3 problem solving is basically using A3 paper. It's more formal way of doing Pdca. Okay, it's also used by Lean Six Sigma. I wish I could do examples, but maybe someday. Okay, Six Sigma level. Now, if we have the tools, and how do we know whether a company that's practicing or doing process improvement or quality improvement, they're spending resources in quality improvement? How do we know if the company is performing good or not? This is where in Six Sigma we call it process performance using a Sigma level. Sigma level is, like say 1 to 6. That's why you hear the Six Sigma. Six Sigma is producing a yield of 99.99% efficiency of products. Hardly any defects. It is actually defined as a equivalent of a 3.4 defects per million opportunities. That is really, really difficult to achieve. But in any case, a company's performance is measured by a Sigma level of business process. That's in Six Sigma, right? So if you're Six Sigma level 1, your yield is 30%. That is not really good, right? So most companies are averaging in the 3 and 4, most companies. And now modern companies like Motorola, they're playing around 5 and 6.
And where this chart really strikes me, the DPMO chart, is, if we think about so many businesses that say, hey, we're at 90% quality, that's great. But when we start thinking about really quality critical products, let's say cars, can you imagine if you're a car manufacturer and you're you're a Sigma level 3 and 93%, efficiency sounds great. But then all of a sudden you go, well, gee, what if a car manufacturer, they sell 1 million cars and they have 66,000 lemons, right? Or let's think about it in terms during this pandemic, the vaccines, those vaccines, they test them to a very high level, right? So that you have very few problems, when they go out. So, when you think about the kind of products that are so quality critical, like Boeing doing airliners or pharmaceuticals or medical instruments, pacemakers, the level of Sigma has to be very high, and you can only achieve that level through a lot of these techniques that Dean has talked about.
Yeah, there's a lot of activities involved, a lot of resources involved to achieve at Sigma level 6. But interesting, isn't it?
Well, and it's real important to think about all these techniques and how important they are to produce those outcomes, particularly when we think about, if you think about a restaurant, just a busy restaurant might produce, 800 meals, 1,000 meals a day. When you start looking at these numbers, you see how these things can be very practical for even a simple business, a fairly basic business, because again, it's based on the amount of opportunities and eliminating those defects.
Unfortunately, during my engineering days, we did not use Sigma level, and because we know we're not going to make it, because the complexity of the product that we develop, just the testing itself of a unit that is supposed to be enclosed in a vacuum enclosure in Earth, to do that, we had to do a lot of techniques in engineering to achieve zero gravity in a enclosure. Now, once they're up in space, there's no problem. But this is where our yield is so low. So because the testing, it takes about 6 to 8 months to complete a test, inertial guidance system. So I said, well, we're not going to do a Sigma level measure as a performance of the company, because we're probably in if you look at it, if I look back on it now, we're probably in the Sigma level 2, or maybe even to 1. Because if we produce 1 out of 3 or 6 units, we're happy. If we achieve that 1. But if we talk about Sigma, we're talking about opportunities as well. And if you producing mass production wise, and you're producing so many different parts, then the Sigma level becomes even more complicated as well, because you want to make sure that the processes and the equipment will yield 99.9% at different times, even at producing many different units.
Yeah.
Okay.
Well, and especially too, when you think about the expense of critical defects, Can you imagine being a phone manufacturer where out of every million phones, you have to do a total replacement of 66,000, and those are $1,000 phones. So the price of not paying attention to quality can be very high.
Right. Yep. And that's why we have those quality people there. That's why we were paying them a lot of bucks. Okay. On the lean side of things, we also measure performance. Use what we call the lean metrics, and there's a lot of them. On-time delivery is a performance metrics. That means delivering on time, as promised. Total cycle time deals with efficiency by producing in the right amount of time, producing products as designed. Yield is the same as the inequality. In the quality side of it, in the performance is what is our yield of production? How efficient are we in terms of producing good parts? Customer rejects is a measure of performance. Supplier quality incoming. Throughput is a measure of a group of people producing parts. Capacity utilization, believe it or not, is part of lean metrics. How efficient are you in utilizing the resources available? If this is a conflict with accounting department, at that time, accounting department would say they want to show that the production is showing that those equipment are run 8 hours or 16 hours a day. That's their measure. That's because they want to see that measure, right? But in lean, capacity utilization is about efficiency and effectivity. By utilizing out of 8 hours, for example, they should be producing parts, not just running and turning on without producing anything. OEE, which is the overall equipment effectiveness, is a performance metrics of how effective the equipment are by measuring the amount of downtime the machine encounters during the day, during the week. If they're not properly maintained, OEE will go up. WIP inventory turns, how fast company turns inventory to goods. Total manufacturing costs, if you do that, the overhead costs. Productivity and revenue per employee, we measure those things. We want to know whether our processes not only conforms to producing parts in quality, but we want to know if productivity is met based on the number of employees assigned in the process, to do the process, and safety. Okay, I think I'm getting closer now. Okay. So having said all of this, and you get a good background now, a little bit more an application side of it. If you don't have any question, I have a question. So if you go back and think about waste and creating value and value elimination of waste and elimination or reduction of variation. Question is how companies can create value and profits. Anyone wants to take a crack at this?